Section 7.3, special right triangles. What we're going to find is that in the process of talking about right triangles, we've got a couple of different types of right triangles that are kind of unique. They have certain characteristics about them in terms of side measurements that other right triangles don't. So to start, we're going to get a little investigation, if you will. Put on your little hats, get your magnifying glass out. A little investigation here, a little CSI action. We're focused on equilateral triangles. If we take an equilateral triangle and we split it in half. So basically, we take an altitude, which would also be a median, which would also be an angle bisector. It's pretty important to know here. And we just drop it like it's hot. Alright? So when you do that, this segment right here is acting not only as an altitude, right angle. It's also acting as a median, which means I know that that's 6 and this is 6. It's also acting as an angle bisector. We'll get more into that here in a minute or two. But if I want to figure out the length of that altitude, I could do p theta. I could do x squared plus 6 squared equals 12 squared. So I get 36, 144, subtract. And now I know that x squared equals 108. We don't want x squared, we want to solve for x, so to get rid of the square, take the square roots. We've been working on simplifying radicals a little bit this chapter. We want to do the exact same thing here. Factors of 108. You can figure this out on your own. I'm going 36 and 3 to get 6 radical 3. So that's the length of this altitude right here. Why is it important? Is there a pattern? I don't know. We'll find out. If we look at another equilateral triangle, let's say this time we've got measurements of 4, 4, and 4. Again, drop that altitude. It's going to split that base in half, so now I've got 2 and 2. Again, if I want to figure out the length of that altitude, p theta, x squared plus 2 squared equals 4 squared. As you work through Pythagorean theorem, we take the square root of both sides. When you do that, again, I can simplify this. That's 4 and 3. I can take the square root of 4, which is 2, radical 3. Do the same thing here. Sevens, different. Even, odd, is the same thing going to be true? I don't know. What's that? You haven't found the pattern yet? Okay, let's try this one. So clearly, again, split that in half. 3.5, 3.5. X squared plus 3.5 squared equals 7 squared. That's going to give us 3.5 squared. 7, 5, carry that. 1, 1, no, 1, 2, 2, 5. 12 and a quarter. So if we subtract that, that gives us 36.75, which should work out to be 3.5 radical 3. I know, kind of weird. But it works. So, notice every single answer. What's that you notice is prevalent? That's right. Square root of 3, square root of 3, square root of 3. We talked about how this would be an angle bisector. How big is every angle in an equilateral triangle? That's right, Zach. Every angle is going to be 60 degrees. But now when we cut this in half, 30, 30. we've created are two right triangles that we would call the 30, 60, 90. 30, 60, 90 right triangle. So, 30, 60, 90 right triangles, they're pretty special. They follow a pattern. Notice here, if this is my right angle, I've got my hypotenuse. This segment was always half of that. Hypotenuse, always half. Hypotenuse, always half. Okay? The altitude was just that short side with a radical 3. Short side with a radical 3. Short side with a radical 3. Short. I think you get the picture. So, when we're looking at a 30, 60, 90 right triangle, we kind of label the sides. At least I give them certain labels. Obviously, across from the right angle, that's your hypotenuse. Across from the 30-degree angle, I like to call that the short side. Because, well, smallest angle, shortest side. 60-degree angle, across from that, we call that the long side. Not the longest side, but the long side. Because in a right triangle, you guessed it, that's right. Hypotenuse, always the longest side. So here's what we know. Whatever the short side is, we'll call it x. The hypotenuse is always 2 times that amount. The long side is always that short side times the square root of 3. So if I draw it again here, maybe make it a little easier for you to see. Whoops. Whatever the short side is, we call that x. Hypotenuse, 2 times that amount. Long side, that number times the square root of 3. Alright? So, we'll get into some examples about that here in a moment or two. There's another type of special right triangle. It's the isosceles right triangle. You got to remember what isosceles means. Gotcha, Sam. That's right. Isosceles. 2 sides congruent. Okay? So you'll see here, 4 and 4. If I want to find the hypotenuse, 4 squared plus 4 squared. So that's 16 and 16, which is 32. Take the square root. Simplify. 16 times 2. That's 4 radical 2. What's that? Caitlin? Yeah, there'll be a pattern in this one too, I bet. You're right. Let's see if we can figure out what it is. 11 and 11. So that gives me 11 squared plus 11 squared equals c squared. That's 121. Twice. So c squared is going to be 242. Take the square root of both sides again. I had 121 2 times. I know that 121 is a perfect square. How do I know that? Because I just squared it. Take the square root, 11 radical 2. Let's stop for a second. 2 4s, hypotenuse, 4 radical 2. 2 11s, hypotenuse, 11 radical 2. So if I gave you, I don't know, 8 and 8, what would be the hypotenuse? Nice. I knew you'd figure it out. 8 radical 2. You got it. What if we switch it up just a little bit? So now we know one side. Now we know the hypotenuse. Can we work backwards? X squared plus 7 squared equals 7 radical 2 squared. So that's easy, that's 49. When you multiply here, 7 squared, 49. When you square a square root, you get just the number that's inside of it, which is 2. So I have to multiply 49 and 2 together. So this is going to give me, we're going to switch colors. X squared plus 49 equals 98. Subtract the 49. Seven. Hopefully that would make sense. Hopefully you said to yourself, self? I think it's going to be 7. If you did, you figured out the pattern. What is that pattern? So glad you asked. 45, 45, 90. That's an isosceles right triangle. It should make sense because if these two segments are the same, these two angles have to be the same. So they're 90 degrees, split in half, 45, 45. Those two sides are always the same. The legs are always the same length. The hypotenuse is that length times the square root of 2. So, if you got any questions at this point, rewind, go back. We're going to take a look at some examples. I got 5 listed here. If you want to copy them down real quick, hit pause. Okay. So we want to take a look at them here. Sometimes it's pretty obvious what type of triangle you're looking at. 45, 45, 90, 30, 60, 90. Other times you're going to pick up the little clues. Like right here, number 1. 30, 60, 90, 45, 45, 90. Not sure. Notice that two segments congruent to each other. If this is 5, that's right. That has to be a 5. So 45, 45, 90. Pair of congruent sides. What's that make the hypotenuse? Multiply by the square root of 2. And you're done. In 2, we're switching it up. Notice here 60 degrees, which means this is 30 degrees. That's right, you know the hypotenuse. So if to go from my short side, short to hypotenuse, multiply by 2, then to work backwards, we're going to do the opposite and divide by 2. So this is 12, divide by 2, this has to be 6. To go from short to long, multiply by the square root of 3, got it. $30, 60, 90. What side do you know this time? Not the hypotenuse. The hypotenuse is right here, across from the right angle. Nice job, Mackie. Long side. You know the long side. All right. So we want to go from the long side to the short side. How do we do that? Well, short to long was multiplied by the square root of 3. So to work backwards, we're going to divide by the square root of 3. When you do that, taking a number and dividing by the square root of 3, this is easy. Why? Because they cancel out. So this is 7. Short to hypotenuse, double it up, 14. All right. Questions? Okay. Last 2. I'm going to give you the answers, and we'll talk about how you figure them out in class the next day. All right, see if you guys can figure it out. Bring it up on your own. Here, 45, 45, 90. Hypotenuse is 10. This is going to be 5 radical 2, 5 radical 2. Last one, number 5, 30, 60, 90. The short side is 2 radical 3. The hypotenuse, 3. The long side is gonna be 6. Go back, rewind it, check it out. Got questions? Find out tomorrow. See ya.